Alright, so this is 3.5, is the lesson we learned yesterday in class, the standard form of a line. And here's the equation, ax plus by equals c. And let's talk about this form before we move on to any examples. You've learned so far that there are three forms to represent an equation of a line. Okay, we always want to write an equation of a line, and when we graph linear functions, we want to represent that line with an equation, and there are three forms to represent that equation. You learn the slope and the y-intercept. So for this form, I think we learned it at 3.3. You can go to the video and check it out. You need the slope, which is m, and you need the b value, which is our y-intercept. So those are the two pieces of information we need to be able to use this form. And you have to decide what kind of form it's best to use, and sometimes in the test they force you to use a certain form. But you need to recognize what is it that I need to be able to use the slope and the y-intercept. I need the slope, and we need this is the y-intercept, okay? And here it says point slope form, so we need a point, x1 comma y1. Okay, we need a point, and obviously we need the m, which is the slope. And there's a standard form right here. We always get something interesting as well. Just like here we got we need two pieces of information. Here we need two pieces of information. Here in the standard form we also need two pieces of information. And this is going to be the x-intercept, and we need the y-intercept. Okay? So those are the two pieces of information we need for the standard form. So each one of these will be, we will have some sort of information to either extract from our equation for our line or move on from one to the other. So they all have some interesting piece of information that we need, and then we can take out from the equation. Okay? All right, so let's take a look at a little bit more information about this standard form. So the standard form is a times x plus b times y equals c. So this value of a, usually we want it to be positive. A is greater than 0. It is one of the definitions of a standard form. We want a to stay positive. But as I was looking in your worksheet, I noticed that sometimes they give you the a value to be negative. So I don't want you to be alarmed. I just wanted to inform you that as you go in higher math, you will see that there is a little bit more strictness when it comes to the standard form. They want the a value to be positive. So I think for this level of math, in Math 1, you will see the a as a negative number, but you also need to be aware that sometimes, most of the time, we want a to be positive if we can. And I'll show you how. The b value times the y. This a and b, I want you to know, these are not variables. They are going to be whole numbers, okay? We want this a and b to be whole numbers. We're going to avoid a and b, we're going to avoid them to be fractions, okay? We're going to try to use some math skills to get rid of fractions and make this a and b values be whole numbers, okay? So let me show you a few examples of what this means, and then we'll move on from there. So for example, here is a few examples just to be introduced to the values. I could have 2x plus 3y equals 6. Now the letter C means I'm going to have a constant here. Okay, the letter C is going to stand for constant. It's a constant value. This constant value can be positive and it can also be negative. It really doesn't matter. Okay, but it will always be a constant. One of the characteristics of the standard form is that the x and the y values are on the left side of the equal sign. And then on the right side, the only thing you have is the constant, okay? So here's another example. I could have 5x plus a y equals 20, okay? Negative 20. Let's make it a negative 20. There we go. So I do have my a value of 5. I have my b value of an invisible 1. And I have my constant to be negative 20. There's another example. And here's another example, one that sometimes the students get a little bit confused because it's too simple. X plus y equals, let's do -3. Okay? I do have an a and a b. Some of the students says, oh, what happened to the a and b? They're there. Okay? It is a 1 times an x plus 1 times a y equals the -3. So I do have an a and b value. Okay? In this worksheet, you may see the a value be negative. So I could have a -2x plus, or even a -4y equals 16. So I could have the a and b value be negative numbers. We don't like it, but in this worksheet, I just want to warn you that you will see it this way. Okay? Can I change this to be positive? Absolutely. We can divide every single one of these by a -1, divide by a -1, and we can make this equation in the standard form with our a value being positive. If you divide every single one of this term by a -1, you will get that -2 divided by a -1 is a positive 2x. A -4 divided by a -1 is a positive 4y. And a positive 16 divided by a negative is -16. So I just want to show you, you have these skills, I know you do, that you can change something that is negative by multiplying or dividing every single value by a -1, and you get the equation to be a positive standard form. So these are just a few examples for us to understand what the standard form looks like with, instead of so abstract with variables, we see it with numbers. Now, let's take a look at it, at some examples here. It says on your worksheet, it says, find the x and the y-intercept of the graph of each equation. Now, all of these are given in standard form. As you can see here on number 4, our a value, let me zoom in a little bit more so you can see. Okay, as you can see here, our a value is -3 and positive 2y equals 12. Okay, we will work with the negative a value. I don't want you to be scared of it. It's just that in higher math, we would like this to be positive and we would change it. But here for this case, for this math one, for this worksheet, we are okay. All right, so what do I do when I have a standard form? What is the purpose of me dealing with the standard form? Well, like I said previously, when we have something in standard form, a times x plus b times y equals c, we want to find the x-intercept, and we want to find the y-intercept. Okay? We want to find these two values, because if I know where my graph touched the x-axis and where my graph touched the y-axis, then I can connect those two important coordinate points and graph my line. When we want to find the x-intercept, we plug in 0 for y. And when I want to find the y-intercept, we plug in 0 for x, for the x value, okay? So that's what it means in the graph. So if I'm graphing something right here, okay, let me just randomly graph a line here. I'm not going to even put an equation, but here we go. I touched the y-axis. This is my y-axis. And I touched the x-axis. Here we go. This is my x-axis. So I want to find out what value is this and what value is this right here. And the only way to find this value over here is if I plug in a 0 for x, because that's what this coordinate here is 0 for x and something for y. Okay, we don't know what it is. And over here, our value is something for x, but definitely 0 for y, because we're in the y equals 0 here. Okay, so we need to understand that the order pairs that we are looking for, an x-intercept will have a 0 for y. So it's going to be x comma 0. And our it's going to be x comma 0. And our y-intercept will be 0 for x and the y-intercept. And that is exactly what we want to be able to find, and then we can draw our line. Okay? So it's easier for us to create a little table, and that's what they start with in your worksheet. They start with a little table. I don't want you to be worried about this little table. I know you understand it because we did it in class. But for those of you that were absent or want to review this, that is where this little table comes from. If I plug in the y, the 0 for y, I'm trying to find the x value. Where am I going to touch the x-axis? So if I plug in 0 for y, I don't like the space that they gave me here on this worksheet, so I'm going to use extra piece of paper here. So I have this equation right here, 2x minus 4y equals negative 8. And let's create this little table, x comma y. I want to find the x-intercept. What is the value of x? I'm going to put a little question mark. That means I have to plug in 0 for y. Okay? So if I plug in 0 in the place of y here, I would have 2x minus 4 times 0 equals negative 8. Then 4 times 0 is 0. So I would have 2x minus 0 equals negative 8. Well, anything minus 0 is just that same thing. It's like I have $10 minus 0. Well, I have $10. So 2x minus 0 is just 2x, and that equals negative 8. Now, if I want to get my x value, that's what I want to find out. What number times 2 will give me negative 8? Well, I need to divide by 2 on both sides. Okay? If we divide it by 2, we get our x by itself. So x equals negative 4, because negative 8 divided by 2 is negative 4. Okay? So that is the value that goes right here, is negative 4. I know I'm going to be touching my x-axis at negative 4. Okay, there will be a point there. Now let's go ahead and solve for when x is 0. What is the value of y? So we're going to do exactly the same calculations, but now we're going to plug in a 0 for x, because we want to know what is the value of y. So I'm going to rewrite the equation, 2, but instead of an x, I'm going to have a 0 minus 4y equals negative 8. I'm going to move up over here, and 2 times 0 is going to be 0. Anything times 0 is 0. 0 minus 4y equals negative 8. While 0 minus 4y is just negative 4y. Negative 4y equals negative 8. And then I want to get the y all by itself. So I'm going to divide this by a negative 4. Divide by a negative 4. A negative 4 divided by negative 4 is a 1. So we're done here. We have 1y. And a negative 8 divided by a negative 4, negative divided by negative is a positive 2. All right? So now I know that this value right here is a number 2. So if I'm ready to graph it, which they're not asking, but I just want to jump the gun a little bit here. If they ask me to graph it, and I am graphing this, I would know that my x-axis and my y-axis. My x-axis, I am going to touch the negative 4. So negative 1, negative 2, negative 3, negative 4. That's my x-axis. Here I have the coordinate pair negative 4, comma 0. That's exactly what my x-axis, my x-intercept is. And on my y value, I want to go to a positive 2. And the positive 2 are up here. Positive 1, positive 2, right there. And that is the point I want to touch right there. So I know my x-coordinate is 0, because right here I'm at 0x, comma, positive 2. So this is the coordinate pair 0, comma 2. Okay? And now I can connect these two coordinates and draw my line. Okay, so there is my line. If I was asked to graph it. So as you can see, that is the use of the standard form. We can find our x-intercept and our y-intercept. So, but over here, for the sake of the worksheet, all they were asking us is to find the x and the y-intercept for each of the equations. So the x we found negative 4, and the y we found a 2. Now in my class here, we already went over these answers, and you saw, and we compare every single one of the answers, and we worked together. Okay? So let's go ahead and do number 7 here for your worksheet. Number 7, we have 3x plus y equals negative 2. Now the students in the class quickly learn a little trick, and I will use this little trick here to see if you get it. If we are plugging in, let's make our little table, x, comma, y. Even though they don't give a little table here, we still will create one so we can keep ourselves organized. If I want to find my x value, I'm going to plug in a 0 for y, because I want to find my x value first, okay? So if I plug in a 0 for y here, immediately this plus y becomes plus 0. And that y just becomes 0, it disappears. So the student says, I just cover it up. And it becomes 3x equals negative 2. So if you cover up, my finger is too fat, but if you cover up the y, you get 3x equals negative 2. And then you can just solve for x. Okay, if I cover up here with the pen, you get 3x equals negative 2, and you solve for x. If you divide both sides by a positive 3, if you divide here by a 3 and here by a 3, you get a negative 2/3. So negative 2/3 is our x value. Why don't we already go to our coordinate plane here, x, comma, y. We found the x value to be negative 2/3. It's not all the way to a negative 1, but it's roughly there. And this grid is so small that it will be really, really difficult to tell. So we're going to put it right between a 0 and a negative 1. Let me see if I can zoom in a little bit more. There we go. All right. So there is our negative 2/3, right between a 0 and a negative 1. Now I want to find my y value. So I'm going to plug in a 0 for x, because I want to find out what is the y value in our y-axis. So if I plug in a 0 for x, we're going to have 3 times 0, and 3 times 0 is going to be 0. So the student says, oh, I can just cover it up, and now I have y equals negative 2. So the value is going to be negative 2, because that's what the y equals, negative 2. So you come over here to negative 2, and you have your little second point on the y value. And we have 2 points. We have our y-intercept and our x-intercept. We can go ahead and connect those 2 dots. Make sure you put a little arrow at the end, because our linears go forever. Okay, our lines go forever. Okay, so that is how you do the same calculations we were doing up here is the same thing you're going to do over here for all of these questions. Let's do one more just to make sure we understand it. I chose number 12 here. We have 6x plus 8y equals 24. They don't give us a little table, but I will create a little table here on the side. And it helps you if you keep your math here organized. X and y. I'm going to label my x-axis, my horizontal x-axis, and my y-axis. I want to find the x-axis first. I want to find the x-intercept. So I'm going to plug in a 0 for y. If I plug in a 0 for y here, this whole term is going to be 8 times 0, which is 0. So it's going to go away, and we're going to end up with 6x equals 24. Okay, because I plugged in a 0 for y. If you divide both sides by 6, we get the x equals 4. And there you go. That is exactly where I want to touch my x-axis at 4. 0, 1, 2, 3, 4. Right there. Okay? Now I'm going to do exactly the same thing, but I want to discover what is the y value. So I'm going to plug in a 0 for x. If I plug in a 0 for x here, 6 times 0 is going to be 0. So this whole term is going to be 0. And I'm going to end up with just 8y equals 24. So 8y equals 24. There we go. If I divide both sides by 8, I will know that y, divide both sides by 8, I will know that y equals 3. And it makes sense. 3 times 8 is 24. So there we go. Our y value is 3. So go up to number 3. 1, 2, 3. And there is our y value. I have my x-intercept and I have my y-intercept. And you draw your little line, put your arrows at the end, and there you go. Okay? So if you always do your little table, you see this coordinate pair beautiful, 4, 0 and 0, 3. That is your y-intercept and that is your x-intercept. Okay? All right, so let's just quickly talk about this. We talked about in class, we made hand-arm motions. X equals -1. Anything that has x equals is your vertical line. So I'm just going to write vertical. And anything that has your y equals is your horizontal. So make sure you remember these. We talked a lot about horizontal lines. The slope of a horizontal line is 0. That's why all you have here is your y-intercept, okay? This would be a slope of 0 because it's horizontal, okay? And it would be right at 5, y equals 5. That's a horizontal line, okay? And your x-intercept would be somewhere here. So it's just to remembering, horizontal is y, we don't have a slope, the slope is 0. And the vertical, x equals, these are undefined, those are vertical lines, and the slopes are undefined. So I'm pretty sure you can go ahead and graph number 15 and 16, and I will just do 16 really quick. I don't have a slope, y equals, we don't have a slope, 0 times x plus 4. That's why the 0 times x is 0. We end up with y equals 4. So the slope is 0. Okay, so that means we have a horizontal line at 4 right here. Okay, there we go. Okay, so this is just a little review concept. It's very important to remember about slopes and vertical lines. All right, so let's go ahead and move on to something different, which is 3.5b. I'm putting both of them on the same, let me zoom out a little bit. Zoom out. 3.5b is a continuation. We were able to do the whole front page of this worksheet in class, but now we are switching between the 3 forms of a line. We need to be able to be good with all these 3 forms of a line. We need to be able to switch between one and another. All right, so let's first go from point slope to slope y-intercept, or for slope intercept form. Let's go ahead and write the equation, the form of a point slope. We have y minus y1 equals the slope times x minus x1. Now this minus, as I mentioned before, is part of your formula. Okay, and you have to be careful if the y1 is a negative value and the x1 is a negative value, because a negative times negative becomes positive. I always say negative times negative becomes positive. Okay? All right, so if I want to go from a point slope form to the slope y-intercept, which is y equals m, which is the slope, times, I'm so sorry. I was going to do something different here. Let's do it again. Y equals mx plus b. Okay, that's the slope and the y-intercept. If I want to go from here to here, there's just 2 steps, and it's always the same 2 steps. First, you want to distribute the slope into these 2 values. So my first step is to use the distributive property. Okay? I'm going to use a distributive property. And the second step of this is to either add or subtract your y1 value. Okay? And I'm going to show you this with numbers. I wrote it in English here, what we are going to be doing as our steps, and then we're going to do it with numbers. So my first step will always be to use the distributive property here with the slope. Okay? You want to distribute the slope into these 2 values, and then you want to either add or subtract the y1 value. I say add or subtract because we don't know, it could be an addition, could be a subtraction. We have to decide that once you give me the actual equation. So let's do an example. If I have y minus a 2 equals 5 times x minus a 3, okay? Really doesn't matter here, I just created one on the spot. I want to go from this form, which is the point, here's my point, and here's my slope. If I want to go from this form to the slope y-intercept, I'm going to first distribute my slope. So let me see if I can get another color pen here. I found it. All right? I'm going to distribute my slope, 5 times x and 5 times negative 3. That's what my first step is. When I say use the distributive property, you should be looking for parentheses, because that's when we distribute a number times a quantity. So we get our y minus a 2 equals 5 times an x is 5x. A positive 5 times a negative 3 is negative 15. So that is the first step. And now the last thing is either add or subtract, depending on what is given, your y1 value. Here's my y1 value right here, okay, because this is part of my formula. So I need to do the opposite of what is done here. If I have a negative 2, I need to add a 2 to both sides. Whole numbers with whole numbers right here. And then we get our y by itself equals 5x. I have a negative 15, but then I just added a positive 2. So I end up with a negative 13. So now I can go ahead and rewrite it right here. Y equals 5x minus 13. And then easily you'll be able to identify what is your slope and what is your y-intercept. Okay? My slope was easy to see even from before. Okay, from here I could see that my slope was 5 and my slope is still a 5. So we can definitely tell that the slope is 5. Now the y-intercept was not easy to see from the point slope form, but it is easy to see it from here. That is a negative 13. So my y-intercept is negative 13. As a matter of fact, you know how to write this, okay? If I'm touching the y-axis, that should be 0, negative 13, okay? We are dropping down negative 13 on the y-axis. That's why it's called our y-intercept, okay? So there we go. The steps are always the same. Use the distributive property with your slope, and then you add or subtract your y value. Your y1 value, whatever that y1 value is, we're going to do the opposite, add or subtract, okay? And let's go ahead and do an example from your worksheet right here. Let's see example number 19 here. They're asking us to write each equation in standard form. Oh, I cannot do that yet, okay? I'm sorry. I need to finish this example right here. So I have to go from slope y-intercept now to the standard form. I was trying to skip steps here. So from the slope y-intercept to the standard form, let's go ahead and rewrite it right here what we have. We have y equals 5x minus 13. I have the slope, I have the y-intercept. Now I need to go to the standard form. Now remember, the standard form is ax plus by equals c. So the x and the y are on the same side of the equal sign. And that's what I want to do here. I want to be able to put the x term and the y term on the same side and leave the constant all by itself. So if I have a positive 5x, we are moving this entire term to the other side. So the step here, the only step here that you need to do is to either add or subtract your x term, the x term, okay? If you already have it in this form, all you have to do is move your add or subtract your x term. We will talk about clearing fractions. If this was a fraction, if my slope was a fraction, I will talk about how to clear fractions. But for this case, all we have to do is subtract 5x on both sides. And they are not alike terms. They're x's and y's. And remember, my goal is to have x's and y's. So my answer is negative 5x plus a y equals negative 13. Okay? So there we go. Like I said, as later on in math, we want to keep this first term positive. We want the a value to be positive. So we can multiply or divide every single one of these terms by a negative one and make it positive. But apparently here in our worksheet, it is okay to keep it negative. So there's your answer. Okay? So in standard form, I would have negative 5x plus a y equals negative 13. So there we go. I moved from the slope-intercept to the standard form by just moving my x term. All right? So let me go ahead and do some examples from your worksheet so we can work out step by step and see if we need to clear fractions. All right, so let's see here. We have number 19, and now we can do number 19. Number 19 says y plus 5 equals negative, open parenthesis, x plus 3. Why don't we go ahead and talk about this equation before we start solving? Okay. Take a look at the slope. We see that the slope is -1 right there. It's right in front of, it's invisible, but it's there. It's a -1. Let's talk about our points here. We have this nice point. They're not asking us for that, but it's a good practice. We have, remember, our equation is y minus a y1, which equals the slope times x minus an x1. So because I see a positive 5 here, that must have been a -5 that was in here in the first place, because a negative times a negative became positive. So that must have been a -5 for my y value. So that's a -5. And for the x value, because my equation has a negative, it must have been a -3 that was in here. It must have been a x minus a -3, and then it became a +3. So my x value is a -3. All right, so the students quickly learned, and I love how students quickly come up with a pattern. They say, oh, so I just look at opposite of here and opposite of what is here. That is true. You always look at opposite, opposite. So if you want to write opposite, opposite, I am okay with it, but I just need you to know where that came from. It's not just a rule that you have to remember. It's because the negative is part of the formula, so you must have plugged in a -3 to end up with a +3. All right, they're asking us to go from the point slope form to the standard. My first step is always to use the distributive property. Okay, I'm going to abbreviate distributive property. Obviously, the only thing I can distribute here is my -1 times the x and times the 3. So y plus 5 equals -1 times x and -1 times a +3. So I'm going to have my -x, and -1 times a +3 is -3. My second step is to either add or subtract the y1 value. The y1 value is a 5. I have a +5. So to be able to get rid of that 5, I'm going to have to subtract a 5 here, and you subtract a 5 here. So there we go. Now the y plus 5 minus 5 gets the y all by itself, and we get our -x minus an 8. So now I have this in I have this in slope y-intercept. I can actually see my slope, which is still a -1, but I can now see my y-intercept, which is -8. As a matter of fact, in coordinate pair is 0 for x, -8 for y. That is my order pair. If I had to graph it, I would go to that. Now they want us to go from that to standard form. And to go to standard, we want our x's and our y's all on the same side. It is a times x plus b times y equals c. So my c will be the -8. I can keep it here. But my x, I'm going to have to move to the other side. So instead of, in order to be able to do that, I'm going to add an x and I'm going to add an x. They are not the same terms, okay? It does not become x times y. It becomes a plus x plus y. So here we go. We have an x plus the y equals the -8. Because all I did was I move over the x to the other side. So you add or subtract the x term. All right? So now I have my x plus y equals the -8. And look at that. If you actually solve your little table for x and y, if you want to find out what your y-intercept is, you plug in a 0 for x. That means 0 is going to be here, and I'm going to have that my y-intercept is -8, just like we saw it here before. If I want to know what my x-intercept is, I plug in a 0 for y. And that means I would cover up my y here, like the students quickly learned. If I plug in a 0 for y, that goes away, and I get that my x-intercept also equals, in this case, coincidentally, also equals a -8. And if I was to graph that, even though they're not asking, if I was to graph that, we know exactly where to go. Here's my x-axis, and here's my y-axis. I would go for my y is negative 8. 1, 2, 3, 4, 5, 6, 7, and there is my negative 8. Okay? But I would also go to my x is negative 8, which is on the left. 1, 2, 3, 4, 5, 6, 7, and there's my negative 8. So I would have these two intercepts, and I would be able to connect these two values. So of course I'm going way and above and beyond here on what to do, but I always like to connect all of the things that you learned so far. All they're asking us is to get to this point right here on the worksheet, okay? So I did switch it, write each equation in standard form using integers. That's why we don't want fractions, okay? So the answer for this here would be x plus y equals negative 8, all right? See, here I said we want whole numbers. That's why we're going to have to learn how to clear fractions for this one, okay? So this is the last one I'm going to do, so this video is not super long. So here we go. I have y equals negative 2/3 x plus 6. So this is already in the slope y-intercept form. The slope is negative 2/3, is the number that multiplies the x, is the value that multiplies the x. And we see our y-intercept of 6. As a matter of fact, we plug in a 0 for x, we get a positive 6 for the y. That's our y-intercept. They want us to switch this to the standard form. Remember, in standard form, we want the x's and the y's. So in standard form, we want ax plus by equals c. I want my number 6 to be my c, but I want the x term to be moved over. So why don't we do that? Why don't we add the 2/3 x to the other side? And we add 2/3 x to the other side. So we end up with 2/3 x plus y equals 6. But we want whole numbers. We want whole numbers. Whole numbers. Okay, we don't want fraction numbers. We want integers. Well, I don't like the denominator of 3. I wish it would disappear. And the only way to do that is to multiply this by a 3. But if I multiply the x term by a 3, you better do the same exact thing to the y term. And if you do it to the y term, you better do it to your constant. So you just choose what denominator you want to get rid of it, and that is the number that you're going to multiply every single term by it, okay? So if I multiply this by a 3, it cancels. We get our 2x. And now we have a plus 3y, and now we have 3 times 6, which is 18. We got it as whole numbers right there. And the nice thing is that the 2 is also positive, so we have a nice standard form, all right? Now, if you want to double check to see if you do get 0,6 for your y-intercept, I guarantee you will. And you can do your little table right here of x and y's, all right? Now, we want to clear a fraction because we want to be nice whole numbers in standard form. So always pick that denominator that you want to get rid of and multiply every single fraction, every single term by that denominator. So the answer for this number 21 should be 2x plus 3y equals 18. Okay? And that should be it for today, for this video. We will continue learning about this worksheet in class, and I might make an extra video to go along with this. And I'll definitely do more practice of this clearing the fractions that we haven't done it yet in class. Okay, good luck.